Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to review something that we've covered on the channel many other times with hopefully a little bit of new information. And the subject of today's presentation is, what is a bridge? So I've covered bridges in the context of virtual machines, LXD containers, as well as Docker. A switch is a bridge with multiple ports. And bridges are used to carry traffic from one network to another network. In Linux, vir-br0 is used for NAT and is provided by the libvirt library and is used to route traffic to outside networks. And if you've ever created a QEMU virtual machine, you've probably seen vir-br0 if you've decided to present your virtual machine out to your main LAN. So Docker 0 is very common when you have Docker loaded on your system, and it's a bridge that routes the Docker internal NAT containers to outside networks. So whenever you have a Docker container and you present a port to an outside network, you're using the address of the host machine, and that's using the Docker 0 bridge to accomplish that. And likewise, LXD BR0 is a bridge that gets created when you do a LXD init to set up LXD, and that's a bridge for LXD containers that routes NATed containers in LXD to outside networks. And so although on the channel I cover bridging your LXD containers to the outside network, the bridge that occurs or is created by default in LXD is LXD BR0, and that's to bridge the NATed containers. So bridges are useful in providing access from multiple devices to other networks. The major takeaway in this video is that bridges are also switches. So this picture that we have here is of the Fred Hartman Bridge, which is nearby me here in Houston, Texas, and what its job is to move traffic from one landmass over the Houston Ship Channel to another landmass. And so the bridge has the characteristic that lots of cars are able to travel over it at the same time in adjacent lanes, and the cars can see each other and they can get to the other side, and they can also return from the other side back here. Likewise, a computer switch is also a bridge where everything on one particular port can hear everything on another port and can hear everything on another port, and so on. And in fact, you can actually plug multiple computers into a switch, and by doing that, you can create a network as long as you have provided them all static addresses, since a DHCP server would not be available in order to grant them addresses. And likewise, a switch will be a piece of track on a railroad which is going in one direction. If we switch the switch, then the traffic can go off in a different direction. And arguably, it's the same scenario on a bridge, where if you're traveling before a bridge and you take an exit to avoid getting on the bridge, you've done the same thing that a switch will do. And so this is the fundamental concept of switches and bridges on networks. So a lot of times on a network, we do have a routing function that controls the switch operation, and that routing function is performed by a device called a router. And the only reason we call it a router is because we move from one network to another network. Well, that would seem to be a switch function, and it is. But in order to have the rules to move to another network, we move over what is called the default route or default gateway. So here we are at an Ubuntu desktop, and I've installed net-tools. So if we do an ifconfig you can see that we have two devices to begin with, the loopback connector and then the physical Ethernet device, which in this particular case is ENP5S0. And it's receiving an address on my main LAN from the DHCP server of 172.16.1.70. Simply put, in order to offer more than one device on our ENP5S0 physical device, we need to have multiple attachments. And the way to accomplish that is to create a virtual bridge. And on the channel before, I've created a device called Bridge 0 that will point to the physical Ethernet device, and that's what we're going to do again here. Ubuntu allows you to modify its networking configuration through a program called NetPlan. And NetPlan's configuration files are over in /etc/netplan. So we've CD'd over there. We'll do an ls. Normally you'll have one file over there named something like 00-installer.yaml. And it doesn't really matter what the name of the file is. It's usually preceded by some sort of a number. And if there's more than one file, it will execute those files to set your configuration according to the order. But for this purpose, I recommend you really only have one file out there. You can feel free to delete the current files you have and create a new file from scratch, or you can do like I'm going to do here. Since we're in a privileged area, we're going to do a sudo command, and we're going to do a sudo copy 10-lxc dot YAML over to 10-lxc dot save. And then we can edit this file with a sudo nano on this file and see what's in it. And it looks like we don't have the nano command installed, so we'll do a sudo apt install on nano. Now it's installing the nano editor, and I come back and do my sudo nano on 10-lxc.yaml. And there's the file. So this is a very simple file. It's a YAML file, and it basically says that my network contains Ethernet devices. It contains one Ethernet device. Its name is ENP5S0, and DHCP is set equal to true, which means that it gets a DHCP address from the main network. And then the DHCP identifier, it will be the MAC address. I'm going to replace the contents of this NetPlan file with a definition that defines a bridge. In order to do that, I'm going to do some Control K's, which deletes the lines out of this file with the nano editor. And then I'm going to paste my new configuration in. So here we go, where we have Ethernets, and my physical Ethernet device, as we saw earlier, was ENP5S0, and here's where it's called out. What's a little bit different is that I'm saying that I do not want a DHCP4 address, and I also don't want a DHCP6 address on the device itself. And then I'm going to have some bridges, and my first bridge and only bridge is going to be named Bridge 0. It's going to use the device ENP5S0 also, and I'm going to set my address statically to 172.16.1.7, which interestingly enough is the current DHCP address. I'll want to go back on my router later on and define a DHCP address reservation to reserve 172.16.1.70 specifically for this bridge. And I might point out that this bridge is going to get a new MAC address. And the reason for that is because it's a new device. ENP5S0 had one hardware MAC address, and bridge 0 has another hardware MAC address, as we'll see shortly. And then we have routes. Well, okay, in your case, let's look at addresses again, 172.16.1.70, and my subnet mask is 16. If you're operating on a network where you've provided an 8-bit network, for example, maybe 192.168.1, where the last number is the only number changing, you're going to want to make that a 24-bit mask. So then we have routes to default. This is my default route. Another word for the default route is the default gateway, and it says via 172.16.0.1, and that is the default gateway, or also known as the default route, and that is the address of my router. And then I have two name servers, and both of these addresses are for Cloudflare. So now I'm going to go ahead and save this out with a Control-O and hit Enter to save it, and Control-X to exit the editor. Just as a reminder, if we do an ifconfig again, we can see that we have ENP5S0 and our loopback connector. And so the command I can use to apply our new configuration file is simply sudo netplan apply. Now that our bridge has been enabled as a result of running the netplan apply, we can do an ifconfig again, and you'll notice that we have device ENP5S0 still with a hardware address ending in 467A, but we now have a bridge 0 device, and it has a new MAC address ending in 8031. So at this point in time, it would be important to go out to your router and set up a DHCP address reservation for the hardware address ending in 8031 and assign it to your IP address, in this particular case 172.16.1.70, since we've statically defined that and we don't want the DHCP server to try and reuse it. So we have here an IPv6 address, and we also have an IPv4 address on our bridge 0, and we don't have any Ethernet or IP addresses, I should say, assigned to ENP5S0, which is by design. So that means that if we do something like a ping of our default gateway, which in my case is 172.16.0.1, the address of the router, we should be able to get a response back, and we do. What that indicates is it indicates that bridge 0 is using device ENP5S0 as its parent to communicate out onto the network, but now we have a bridge, or otherwise known as a virtual switch, to facilitate the traffic. So let's use our bridge, and we'll start out by doing that by installing Docker on this machine with the curl command and running the Docker script on the Docker website. I type in my sudo password, and then the script runs to install Docker. The installation of Docker also makes a modification to our network, and we can see that by doing an ifconfig again. And you'll notice that now, in addition to the bridge 0 device and the ENP5S0 and the loopback connector, we now have a Docker 0 device. And the Docker 0, as I pointed out earlier on in the slides, is the bridge to the Docker NAT network, which has an address of 172.17.0, and the 172.17.0.1 is its bridge from the Docker NAT network back to your main network. After installing Docker, you may also want to install Docker Compose with a sudo apt install docker-compose, if you're planning to use the Docker compose command as well. And a very important step in using Docker that a lot of people forget to do is you can add your user account to the Docker group, and that prevents you from having to use the sudo command every time you use Docker. So in order to do that, we can do a sudo user mod -a capital G Docker, and my user account is Scott. And then I can do a new, well, you can say groups, and you can see that I'm not in the Docker group here. I could log off and log back in again, or I could simply type new grp Docker and then type groups again, and you can see that Docker is a part of my current group list. I can see the networks with Docker if I do the command docker network list. And by default, you always have none, which means no network, and then a bridge network and a host network. But you can actually bridge your Docker containers outside of the NAT that they're normally created on with the command docker network create. In this particular case, I'm using the network driver, and I'm saying bridge it to the 172.16.0.0 network with the subnet mask of 16, because that's my network on my main LAN, and then my gateway is 172.16.0.1, and the parent is going to be bridge 0, and the name of my bridge will be doc-bridge. So when I do that, if I turn around again and do a Docker network list, you can now see that I have a doc-bridge as an additional network. I don't want to get too much more into Docker networking because on my channel I have created a video in the past entitled Docker networking. But just to show you, you can do a docker run -it --network equals doc-bridge, our new bridge network, and we can launch BusyBox. When BusyBox comes up, I can do an IP space A, and you'll notice that the network that it's assigned, or the address that it's assigned, is 172.16.0.2. This address did not come from the DHCP server on my main LAN. Instead, this address came from Docker. And so that's one of the reasons why I generally prefer creating a LXD container, which is bridged to the main LAN, getting its own unique address, and then I like nesting Docker containers inside of it, and that gives each LXD container its own unique Docker host address, which is the host address for the LXD container. So here I have an example of setting up LXD. It's basically two commands, sudo snap install LXD to install LXD, followed by a sudo LXD init. So both of these commands are required, and I've covered them on the channel many times before, but once you have both of those set up, then you have LXD installed and ready to use on your system. After you've installed LXD, it's usually a good idea to put yourself in a LXD group, and we can do that with the LXD user mod -a g LXD and my username Scott. Now I'm going to do a new group, new grp space LXD, and I can type groups, and now you can see that I'm in the LXD group, the sudo group, the Docker group, and of course I'm in my own group. All right, so now that we've done that, we can do a LXC profile list. And you see by default we have only one profile called the default profile. As I have demonstrated before, the technique to creating a new profile for LXD is to simply do a LXC profile create. And in the past, we've created the bridge profile. We're doing that once again here. So I have a bridge profile. And we're going to set that up simply by saying LXD profile edit bridge profile. That goes into the Nano editor. I'm going to clear everything out of that screen here and simply input the configuration that I need. So this is a very simple configuration for bridge profile. It looks like this. It says bridge to main LAN. ETH0 is the device that's used inside of containers. It's using a NIC type of bridge, and it's using our parent bridge that we've already created with NetPlan on the host called bridge 0. So in order to save that, I do a Control O and hit enter, and then Control X to exit the editor. And now if I do a LXD profile list, you can see that I have two profiles, one called default and one called bridge profile. As a reminder, if I create a LXD container very simply with LXD launch Ubuntu 22.04 and give it the name test1, it will go ahead and download and launch a container called test1. But that container is on the internal NAT and is unreachable from outside of the network. So what we're going to want to do is we're going to want to create a second container, and that second container will be a container that uses the profile called bridge profile and therefore is accessible from out on the main LAN and is granted an address by the DHCP server on the main LAN. So now that we've created the test1 container, which is a NAT container, we'll go ahead and create test2, and all we do is back up here and say -- profile is going to be bridge profile, and that'll go ahead and create test2 with the bridge profile. So it says invalid devices because it's missing a root device. That's a very common error. You really have to say -- profile space default and then -- profile bridge profile. So we need to include both the bridge profile and the default profile. When we created the first container, if we don't create any, we don't mention any profile, it will use default by default. But in the second example, we have to include default when we include bridge. So here it's going off and creating the second container. This one will be faster because it didn't have to go out to the LXD container hub and pull the container because it had already been pulled when we created test1. Now, if we do a LXD list, we see that test1 has an address of 10.28.71.25, which is a LXD container with a NAT address. And if you want to know where that NAT address can communicate to on the network, if we do an ifconfig now, we notice that we not only have bridge 0 device and Docker 0 device and our ENP5S0, but we also have the loopback device that we had before, and we have a new device called LXD BR0. And then for each device that we create on the network, each container we create, we're going to get an additional device. So now, if I clear the screen and go back and do a LXD list, you now notice that test1 has the NAT address like it did, and test2 has no address. Test2 never did get an IPv4 address, and one of the reasons for that is because you can't run Docker at the host level in parallel with LXD because you'll have issues with LXD networking, and I have mentioned that on the channel before. So now if I do a LXD list with my Docker completely removed from my host, you can see that I have test1 and I have test2. So let's say that we really did want Docker. Again, my recommendation is to nest Docker inside of a container like this test2 container. And we cover that in depth on the channel, how to use security.nesting equal to true, and how you can install Docker inside of a LXD container. One of the biggest advantages of that, of course, is that if you have one container served from the test2 LXD host, then you end up having a dedicated address for your Docker and you don't have to worry about port conflicts. In summary, learning how to create a virtual switch is valuable in presenting virtual machines or containers to another network. A switch connects traffic from multiple systems, and a bridge presents the traffic to another network. They are really the same, and a switch can be considered a multi-port bridge. Understanding virtual switches and bridges is important to create your system's architecture. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we will see you next time.